The other time we're looking at imbalanced data set, and we want to look at the continue to look at the classification report. We said that the accuracy is not the best metrics for us to actually judge between the two models. We trained a model with our class weighting, we got 91.9, and we trained one with class weighting and we got 86.7%. So it looks like the one without class weighting is better on accuracy, is better compared to this. But we're saying that, excuse me, when we have imbalance in the data, we don't use accuracy. Accuracy is not the best metric for that. So this model was trained with class weighting. That's the class weighting, and the other one was trained without class weighting. So this was trained without class weighting. So what we can now do is that we can use classification reports to be able to help us see what's going on there. So what we again to do, so we look at the one with class weighting. So we'll go with our predictions, and I would say no weighting. So the prediction with no weighting, no class weight. So we have that. Then we can just use our model, and we use the prediction to predict on the static X test. Yeah, and I think that should also take the Y test as well, and the Y test. So the Y test. So that should give us that prediction. Where's that? There is a problem there. Should we have our predictions? Mm, Where are we having this? We're supposed to have the test, right? Okay, sorry. So we're supposed to have the, this is the prediction, sorry. We're not supposed to pass the Y tested. So then that's the prediction. We can now look at our predictions. Let's see what that gives us. It gives us it gives us the predictions, and we're supposed to now use the the sigmoid. So this is referred to as the logit, so we now use the sigmoid on that. So also, so copy this, and the one I can lay hold of There are many ways this is done. You can use tf.nn.sigmoid. I'm actually looking at this house, so we can use that over this. But I need to import this tf.nn. Oh no, I have TensorFlow imported already now. So let's import TensorFlow. There's some import we still have to do here. So import TensorFlow stf. We can use this. Okay, so that works. And let's now see what this gives us now. Okay, so we now have this as a sigmoid. Then we can now still use the TensorFlow to say that we use the tf.where, and we pass in our prediction, and we say if it is less than 0.5, that should go to class 0. That should give it 0, and if it is more, that should give it 1. So now when we now use our, we now look at class weight now, so it's either 0 or is it a 1. Okay, so that's what this is going to give us now. So that makes some sense. So our true value is the y-test. So this is the y-test. Let's see what that looks like. So we need to turn this prediction into an NP array so that it can look the same way as our y-test. So we can say our y-pred will be equals to np.array of prediction all. So do we have numpy imported? Yeah. So our pred now, we now look the same way, like, does that work? It is not yet. Not yet. That is still not correct. We need to do something about that. Let's see what we're going to do. Just trying to do some check. I think we need to reshape. Yes, we need to reshape before. It's actually an array now, but we need to reshape this. So we need to reshape the last axis. So we reshape that just to make sure we flatten it. So it's a way of flattening that. So that gives us what we need. So we can assign this back to y-pred. So we reshape that, and so we check our y-pred now. So it's now the same way like our, it's not the same like our predictor. So we can now import from sklearn, from sklearn.metrics, we can import confusion matrix. Import confusion matrix. We can also import the classification report too. Yeah, so we can just pass in into our confusion matrix cm, then we can say the confusion matrix. So let's run this first. So confusion matrix, and we pass in our y true. This is the true, Our y true is actually the y test. Then we're pressing our y spread. Okay, so this gives us the confusion matrix, and we can see the confusion matrix. You can see here now that that model is not doing anything. It's doing badly. It's just predicting everything as just one class. It's just predicting everything as just one class. There's a way we can add label to. I think there's a way we can add label here. Label here. I think that's a list, right? Labels is a list. So labels is a list. Labels. That will be 0. How does that go? Take it 0, 1. That's it. That's it. So the first one is 0. The second one is 1. So the 1 is the 783. Let me reverse that. The 1. Yeah, this one 0. So that should change. Okay, good. So this first column is 1, this one is 0. So the 1 is the positive, the 0 is the negative. So as you can see here, the 1 has 738 samples, the 0 has 1895 samples. Okay, so we can print our classification report for that. So let's print the classification report. For that, we send in the y test, and the y true. Okay, and the c, sorry about that, the y true. So you could see here what's going on. Y true is not defined. Y test. Oh, sorry. Y true is the test, and Y predict. So Y predict is our prediction. So you can see here. So this is the majority class. You see, the majority is just blank, 0. Precision is 0, recall is 0. It's not getting anything of the majority. So that's why accuracy is not the best metric. In fact, the accuracy that we saw there is actually the training accuracy, not even the test accuracy. But I think we also did the evaluation. What did we say? Yeah, it's a test. 91. So accuracy is not the best metric. You could see here that it's bad completely. The F1 score is bad on the majority class. Okay, and on the minority is doing some stuff, just classifying everything as one class. So let's see whether there's a difference with the second one. So I will just copy all this code from here. I will copy it up to, okay, let me just do this. So what I will just do here, it's we use the same code, but this time around we just change the variables. So here is the model with class width. So we can do that, and we remove this. So this is the one with the class width, and we can have that. So model with class width, and we can also use the sigmoid as we did before to do that. So we just do the same thing. This, we need this, and we also need this. So So we change, create a space here. So here we change the one with class width. We change this with class width. Change this with class width. We change this with class width. And we can run this. We can run this. And class width. Then we can say wipe read, the one with class width. So this is the one with class width. Wipe read, the one with class width. Okay. So we have this with class width. Then we can also reshape that. We're just doing the same thing. So with class width, we reshape that. Now we put it back inside the variable with class width. Reshape that. And we can now get the confusion matrix for that. So we can have the confusion matrix, and all we need to say is the confusion matrix with class width, and gives us what we need. So the confusion matrix, so we get a wide spread with class width. So the wide test, which is the true, is the same. So that gives us that, and we can plot that CM with class width, and we can see whether, well, that didn't do well too. Both of them did not do well. So you can see the effect of class imbalance in it. So both of them, they just categorize one class as just the majority class. Okay, that is bad. That is definitely bad. Okay, in the next class, what I would like to do is I would like to use autokeras and see if autokeras. So the two of them are bad, even though they are different accuracy, and I'm surprised why this accuracy is different from the other accuracy there. Quite surprised. All right, so and that's that about this. Thank you very much for listening. Please do leave a comment, and we shall continue from there next time. Thank you.